Welcome to proglangcast. This is episode 6. I'm one of your hosts, Christopher Augustus.
And I'm Steve Thames, presenting our Bye Bye Hello World alternative introductory application to languages written in F#.
F#.
You want to just take a look at the code? Okay, so
this is what you got.
This is our version of the code in F#, or my version of it, I guess. This is my first foray into functional programming and my first foray into F#. So this is what I came up with to handle the requirements of Bye Bye Hello World, which is trying to be a little bit more expansive introduction than the normal Hello World program.
So are you going to execute first or talk us through the code?
I would just talk about the code a little bit. This section of code right here is just determining where to get the command line arguments based on the environment in which the program is running in, either in scripting or as a Windows application.
I think actually it would be helpful for me, maybe the watchers, if you execute it first so we can see what Bye Bye Hello World is, assuming someone hasn't watched our previous videos.
Okay. Let's see what it does here in the Linux environment. So this is demonstrating the command line arguments. I'm going to put it in as 5.
And this is WSL, Windows Subsystem for Linux.
That's correct.
Tickety-tock.
Yes, it takes a bit of time.
There we go. So I see run. That's a shell script, right?
Yes, that's a Linux script, and then run.cmd is a Windows script.
And then which file is the source file?
The source file is bbhw.fsx. There's actually two extensions for F#. .fs is the obvious one. FSX is the scripting one. So here's the run command. And you see right here, it's actually making a call to .NET and running the F# interactive mode, and then executing this script. So .fsx is what you use when you're going to run something through the scripting engine. .fs is what you would normally use if you're building an application.
So we think that's why it's so slow? Is that FSI is really slow?
Well, besides the fact that my computer is really busy, yes, FSI is slow.
Should we run it in the other modes? How many other modes can you run it in?
WSL, right? As far as DOS is concerned, this is the Windows environment, and it's the same thing. So if I do run, well, it went a little bit faster. This is a Windows environment.
Oh,
so
that was 10 times faster, at least.
Yeah, in WSL, it's not running fast. Now let's try. Yeah.
You didn't give it a command line argument.
Okay, let's do that. We can do that. That's gonna see how quick it does that now.
Seems slower. It's not like parsing command line arguments takes time or anything.
No, we can. Oops. So yeah, it's significantly faster here. Now this is PowerShell, but PowerShell is just going to run the same command.
4, 5, 6, 7, 8. Well, I'm going to predict that we're going to get a lot of critics watching this who are F# programmers saying, yeah, don't run this as a script. Have you tried compiling it into an XE and see what happens?
Yes. Let me get set up for doing that.
There we go. Improvisation.
Yeah, that's true.
Well, okay, I was considering F# as a scripting language, potentially so I don't have to write PowerShell scripts when I have to do Windows administration. But this lag and startup time is disincentive.
I hear that. Yeah.
Yeah.
Okay, it's done building it.
Okay. Well, quicker. Yeah.
Right. So so I can address this issue. Let's just see that. Let's see that again. Let's see it under DOS, although it's not really any different.
DOS.
Yeah, or command shell rather.
Only us old timers know what that is.
You think so?
I don't know.
True. Okay, so here we are again running it as an executable. Boom, and it comes up real fast.
Instantaneous.
Yeah.
Do that again.
I will. Hold on, I'm gonna.
So actually launching it from PowerShell was slower than Command Exe, of course.
Boom.
Oh, yeah.
So it's instant. As I said, F# was actually written as an application language. It was not written as a scripting language. In fact,
So like C#.
in fact, here's something interesting I learned when I started working on this. In order to run it as a script, you have to install .NET. You have to install the .NET SDKs. You can't just install the .NET runtime, because the .NET runtime doesn't include the scripting shell. Right. And
that's interesting.
It turns out that the reason that they did it is so that you could actually run the script in interactive mode from within Visual Studio and test your code that way. In fact, I remember reading one post where a guy said, yeah, don't use it unless you're testing. You don't want to use a scripting language to run anything. It's way too slow. That's what he said. And that seems to be borne out here.
So let's not beat up on it and as a scripting language. I guess just walk through the code as if the exe was the intended target.
Right.
You can just address the language itself.
So starting on line 10 here, you just see a couple of functions. I wanted to put those in order to show more of a functional environment, although they're only used once. So let's start right down here at the bottom. I'm going through all of my declarative parts here, a couple of functions, and there's a function down here. And then down on line 24 is really where my code starts, by loading in the command line argument, arg. And it comes in as either if the arg's length is greater than 1, then it calls this method getCountdown to pull it in. Otherwise, it sets it to none. None is the integer value is a discriminated union, I think is what it's called.
Discriminated union?
Yeah.
That may be one of the things it's called.
Right. And so it's called an option. Yeah. If I were to declare it, I would write it as it is an integer of option. So it's an option of integer, meaning it can either be an integer value or this value none. If we look down here at line 24, we're bringing in arg. And we're saying if it's greater than 1, we're going to call the getCountdown method. Otherwise, we're going to set it to none. And so when checking the value of arg, it's going to be none if there was nothing on the command line. Or it could be some integer. So this is how this is represented as a distributed, would you call it a distributed?
You called it a discriminated.
I think it's discriminated union is what they call it. Like I said, I'm real new to this language.
Well, I immediately find that very readable. Like you literally saying, if your args are greater than 1, getCountdown, otherwise none. If it's none, read input. That's pretty readable.
Yeah, I have to admit, as disappointing as the scripting mechanism was for F#, I like the way it came together. I like this approach to developing an application. And then it's real. So let's taking a look at the getCountdown. This is simply a function that's going to take an input of string. It's going to try to do, now this is where you see the int32 try parse. That is from system.int32, which is part of the .NET environment.
Oh, you're saying that's .NET. It's not built into F# by itself.
That's correct.
Oh.
Yeah, anyone familiar with the .NET environment is going to recognize it. That's the same thing that you would call in C# or any of the other CLR-based languages. Microsoft will tell you, if you go out and look at the instructions or the information about how to code in F#, they'll tell you how to work with these option style variables, okay, where they're going to be equal to sum, which means it's, in this case, it's an option of integers. So sum I means that I is an integer, or it's going to be none. And the reason for this is because, like a number of other languages, especially functional, I guess, the null value, which we're used to seeing in C and C#, is not available. You can't simply set something to null. And so what it's very interesting too, because the reason behind null is that it's something you can always check to see, is it null? Then I don't want to do this. But that requires something proactively done by the programmer. So the options are an alternative way that doesn't require that. However, the way that Microsoft tells you to do it, they've got a couple of things for, like, I could do an arg.isNone. I could say if arg.isNone, or if not arg.isNone. But that's the same thing again. That's a proactive thing that the programmer has to do. So the fellow that I recommend everybody look to if they want to work in F# is a guy named Scott Washin, and he has a website, F# for Fun and Profit. His presentations are really excellent. He can walk you through the best ways to use F#. His website's pretty amazing, and it really helped get into the feel of this. And one of the things that he makes clear is that those declarative way, or those imperative ways of checking whether or not an option value is valid is not the way that Microsoft tells you to do it, because looking at, say, arg and saying if arg.isNone is exactly the same as saying if arg is equal to null.
No, yeah.
Right. It's the same imperative way of evaluating it. So he says that when you're working with that, this match function is really what you want to work with. And so that's
matching.
And the other effort is, of course, F#, like many other newer languages and functional languages, everything is immutable. All the variables are immutable unless you tell the system, unless you literally say, well, I couldn't do it there. If I said let arg mutable equal, okay, then I would be able to change it. But I didn't want to do that. The exercise that I was doing was trying to make it so that everything was mutable.
Immutable.
Yes.
Well, that's impressive. So there are no mutable variables in this program.
No, not in the imperative sense. When you get down here, obviously I is mutable, but only from the standpoint of the for I down to. So I doesn't exist anywhere else. I don't declare it anywhere. So that's
technically, even in that for loop, I'm not sure about F#, but in other languages, you wouldn't necessarily consider that mutable, because the lexical scope of I under the for gets a constant value during the duration of that scope, right? And you're not assigning a value to it. You're not modifying it. It's not necessarily a mutable variable as much as you're getting a new value on each iteration. Does that make sense?
Well, yes, but here's the question I would ask. Could you do this? Could you say I
equals I plus 1 or something?
I plus 1. Could you do that?
See what
and if you did, what does it say? It says assigns a value. This value is not mutable. So how would I make it mutable? How about if I said for?
Don't make it mutable.
No, I don't know how you would do it in this statement.
I think you would you'd probably have to declare it outside the loop. So the iteration, the index value here is an immutable value. So makes my point. You have no mutability throughout here, which is a pretty good demonstration considering we're doing I/O, we're taking input from the user. multiple times if they enter the wrong value, and yet there are no mutable intermediate variables here. There's side effects. IO is side effect, but non-mutability, this meets that test. So I think that's impressive. I
And
like it.
interestingly enough, I actually could have written, the funny thing about the first video of Scott Washington that I watched was F# for C# programmers. And so people that are steeped in the ways of doing things and the very imperative way that you do things in C#, he brings them over into F# and literally tells you how you can write exactly the same code in F#. But it's simply C# code in F#. And I could have written it that way. I could have written something that looked very much like something that we did in C or we did in PHP. But I wanted to code something more in the feel of F#, because I was thinking about the previous episode that we did with APL, and how the fellow that we had talking to us about it, Adam, he came in and showed us, yes, that you could do it that way, but this is more the APL way of doing it. So I was trying to,
way.
yeah,
Yeah.
so I was trying to do something more in an F# feel. But like I said, and I actually thought about doing it C in F# as a demonstration, but I didn't. Once I got done with this one, I was like, I don't want to do that. It's just, that doesn't sound like any fun.
What do you mean C and F#?
Well, exactly what I was saying that Scott Washington was saying. He was literally showing people how to write C# code in F#. And I could have done something more like that, with mutable variables.
Style.
Yeah, that style with, going through loops to check the argument, stuff like that. But I wanted to, so I worked on this a little while to try to get it more in the feel of the F#. And I can tell you that the effect that it had on me was I just really liked it. Because I very much appreciate the declarative style of programming, where I'm just going to set all of these values. This is going to be equal to this. This is going to be equal to this. In the code that I write generally, where I'm doing things with bitwise operators, I'll typically do like 5 or 6 of them. This one is equal to this or this. This is equal to this or this and this. And then just keep using them. It's all sort of a declarative way of approaching it. And so I like that style.
Yeah, one of the phrases we hear a lot in functional programming in general that comes up is this idea that when you use immutable values instead of mutable variables, and if you can make functions pure, then code is easier to reason about. That phrase, reason about the code, meaning when we look at code, we can more easily understand what's going on when we follow those principles. That's one of the selling points or marketing points of functional programming. What do you think of that? Do you think it's easier to reason about the code?
Well, another one of the videos that Scott put out, which I found fascinating, was using F# in a domain modeling environment, which is almost purely declarative. Okay, and so yes, I actually really like it that way. In fact, I was going to say that for my next assignment in a language to do BBHW, and I'd like to do another functional language. I'd like to get more into that. Obviously, the more imperative programming style is one I'm terribly familiar with all the work I've done in C and C# and Pascal and all that good garbage. So
garbage. Oh, it's a little unkind.
Well, don't get me wrong. I mean, I've always liked C, but and you and I have talked about functional programming a lot over the last couple of years. But the thing is, as I get into it, the thing is, when I started doing object-oriented programming, it kind of fit with my thinking, because I always tend to think of objects when I'm starting to design a system. And so in that sense, there's that declarative part. Here's the objects that I'm working with. When we get into the functional stuff, it's very much in the declarative way. And I really like it that way. And the interesting thing is, when you saw me just do an assignment, the equal sign is not an assignment operator in F#. It's a declarative operator. And like you just saw me do that I equals I plus 1, it's actually an assignment to the left-hand side from the right-hand side using that arrow dash.
Yeah, I think that often throws us off when we're coming from imperative languages initially, that the equal sign, we're so used to assignment. So here you were saying if you wanted to make arg or countdown mutable, you'd actually type in mutable, right?
Oh, yes, you'd have to do that here. And don't you have to do the same thing? Like Rust is another language that is basically immutable, right? You,
Immutable by default.
by default.
So yeah, we could actually categorize languages, I think in terms of mutability, 3 categories, right? Those that allow no mutability, which is very few. That would be, to my knowledge, Haskell, Idris, I think Elm, Richard Feldman's new language called Rock that he's working on, which is highly influenced from Elm, also no mutable variables. Erlang has no mutable variables. Then the others where immutable by default. And this is one, right? F sharp.
Mm-hmm.
Rust. I'm thinking.
Yeah, I can't think of any others right now either. In fact, in my professional world, I have never had to deal with anything that where the default was an immutable value.
Okay, then there's a 4th category. The newer languages where mutability is determined by a different keyword. So in Kotlin, if you say val, it's immutable. If you say var, it's mutable.
Interesting.
In Swift, if you say let, it's immutable. And var, it's immutable. Of course, they had to make sure that at least one of those was different than the other. So, and then the languages that we're most familiar with, where mutability is the default.
Is the default.
And the only
yes.
way to get around it, as we know in C++ and C, is const. Oh, and there's a 5th category. Languages that don't support immutability at all. Python, JavaScript. You've written a lot of C#.
I have.
So now that this is the first F# you've written, and I've not written any F#, but I have watched the Scott Woloshin videos, which I recommend just for functional programming. Even if you don't do F#, he covers all the essentials, talks about other languages. He has a deep background like we do in OO for decades. And so he's coming from that. But the question I'm asking you is, how does this feel different than C#?
My first reaction doing something like this, and it was very interesting watching his video where he tells you how to write C# code in F#, because the more I got through it, and then when he started showing you the declarative model when I watched the second one, my reaction was, well, I don't want to code C# and F#. I want to code in a declarative way. I mean, I just found when I set myself the task of write something functional that's immutable. Okay, can I do that with an application this small? Can I write something that's totally immutable? And I loved it. I mean, at first, when I first thought about doing it, I thought, well, that's going to be a pain in the ass. I'm going to have to make sure, oh, that needs to be mutable now. So I'm going to have to change that, add mutable, or do something different. And then as I started thinking about, well, do I really have to make it mutable? Can I do it another way, which maintains my immutability? Now, there is probably a turnover point where it's not worth the carrot to work so hard to make everything immutable. But I haven't reached it yet. I found this, I mean, this is a very small model that you're trying to code in. The answer is I wouldn't mind the environment and learning more about how to code this stuff in F# and be in a more declarative environment. Now, that being said, if I have to work in the .NET environment, where I want all the other programmers I'm working with to be able to do it too, then I guess I would prefer C#. But if I was working in an environment that, I had good functional programmers, people that were familiar with F#, then yeah, I'd love it. I think I'd definitely prefer to do something more in F#.
Is there anything in .NET world that you could do in C# that you can't do in F#, or can you do everything in F# if you wanted to?
If you listen to Scott, The answer is no. Everything you can do in C#, you can do in F#. And the truth is, Scott's video shows you exactly how to code an object-oriented program in F#. So it's
I would
definitely
think
possible to do all of them.
there'd be a difference between accessing objects that already exist, like in the framework, right? .NET is a giant framework. And I'm imagining a lot of stuff comes across as classes, right? Objects and classes.
Yes.
And you could access them from F#. But I think it
Yes.
would be different to create your own classes in F#, which I think you can do, right? But
Yes.
that would be considered not
Yes.
idiomatic.
Yes. That's absolutely true. They are available. I would like, if I were to do something that currently used classes in C#, I wouldn't want to do it that way. I'd want to write them all. I wouldn't want the functions to be tied to the objects. I would want to do them outside of it, more in this
Right,
functional
exactly.
way.
Let me ask you, what do you think of the syntax? I don't see any braces. I don't see any. I see one semicolon.
There are some cases where you need to use braces. I can't think of them right now. The only time that you ever need even parentheses in a situation like this, like on line 13 here, where you're seeing I'm having to specify the input value as string. Now, this kind of brings up another issue, and you had a name for this. We were speaking about this not long ago. The fact that the compiler is determining what that value S is by looking at the context of the code. What did you call that?
Type inference.
Yes.
So to my understanding, F# falls into the category of statically typed. In other words, the types are determined when it compiles, long before it runs or is interpreted. At compile time, it's going to say these all have to have defined types, and defined types have to be compatible. And it's also strongly typed. So for example, I see where you've got int32 try parse. You can't just assign a string to an integer or interpret or do add, do subtraction or arithmetic on strings, and like in JavaScript where we go, oh, they look like numbers, I guess they're numbers. So strongly typed, saying you have to convert explicitly if necessary.
Yeah.
Otherwise, they must be compatible types. But you're right in the point that I don't see hardly any type definitions or declarations. So that means the compiler, based on usage of like the literals, where you've got a number literal, it's going to assume that's some kind of integer. Where you've got a literal string in quotes, it's going to say, okay, that is going to be a string. Are there Booleans in there? There's a true. Okay, so that's a Boolean. What else do we see in there? Do we see any floats? I just see a couple integers.
No, there are no floats in this.
Strings and Booleans. And to your point, the union type, also known as a sum type. In functional circles, it's more commonly known as just a sum type. It's the same thing as union, tagged union, discriminated union.
Yeah, I look forward to learning more about that. To get back to your original question, in this particular case, in the get countdown method,
do see string, yeah.
It can't determine. The reason it can't is because there's a number of different signatures for try parse. Gotcha. You can pass in a string, you can pass in a character array, you can take in a couple of other parameters. So in other words, so for that reason, I've got to tell it what type it is.
It can't infer.
Exactly. Now, like in this case, up here in the is not good, it can see, obviously, that this is a string, so it knows. Same thing here. This is because this value, the compiler sees that 0 as an integer. If I were to put an M after that, then it would see it as a decimal value. So now I would suddenly be decimal. And if I put it in a 0.0, then I would suddenly become a float.
And
so that's all.
A problem down below?
Yeah, down here it is.
Oh, it immediately says you're trying to use it as part of a range for iteration, and you can't range over floats. unless you're doing quantum computing or something.
I guess the down to, I'm not really sure. Yeah. Should do
Well,
quantum
yeah,
computing.
it's saying I want an integer. So I actually now see two types specifically in there: string and int32. At least the
Right.
conversion function named int32 implies that type. What if you just say int? Do you have to say 32 there? Does it have to be a
That
specific size?
there is no, well, here's telling you what int32 is.
Like, what if you made it int 16 or 64?
Yeah, int 16 is there.
And it,
Now we got a problem here.
why?
Well, because the I here, this expression was expected to have type integer, but here it has type int16. Why does it expect it to be integer? Guessing because it's here? This is expecting an integer, not an int16. I don't know how you would represent. So this is the one of the things that you might find a little confusing when you're, I mean, I certainly did when I first started working with it, because the compiler, when you're doing this in Visual Studio, the other one, I mean, you could do this in a straight like Vim or some other just ordinary text editor, but then you'd have to run it through the .NET compiler, and you would get all of these error messages. But the compiler is telling you this the whole time. So it's things just like this, where this is now, it expects it to be an int32, I guess because of this up here. But
well, you know, in C and C++, we know that there is what's called the native integer size. So if you don't specify, it becomes the natural machine size of the compiler, interpreter, operating system, whatever.
maybe that's what
And
it is.
Well, what I'm thinking is if you don't specify up above, you've got just the 0 as the integer literal.
Yeah.
So therefore, inference is saying this is going to be the natural integer. But when you went down to the conversion function, system doesn't provide try parse for just natural integer. You have to give it a size.
You have to give it a size. Yeah, there's no int try parse.
So that's a lacking of the system library, because clearly there's an int type and it must match int32 in this case. So there's a little bit of friction between the built-in inference of the integer literal and the system function you're having to use for try parse. Now, of course, if you wrote your own parse, you wouldn't be limited by that.
That's true.
Like
and I actually thought about doing that. The reason I didn't is, well, for two reasons. One was because I wanted to maintain immutability. So for that reason, it would have been difficult to maintain immutability if I was actually doing a string scan and then adding a digit value in and saying times 10. That would have been much more complicated. So I wanted to just isolate that. But that brings up a good point. If I wanted to write my own parser, then I would struggle to maintain the immutability. You could probably still do it by using a recursive function like we have down here. This function is recursive.
Oh, that's what rec is.
Yeah, it is. They actually, F# wants you to tell it that something's recursive. I found that interesting. I don't know why.
Question. Is it tail recursive? And does it require, if you say REC, for it to be tail recursive? Because I notice you're calling yourself at the end there. And does that qualify as tail recursion? In the recursive functional world, one of the problems with recursion, of course, as you well know from building things in the assembly language level, that basically every time you recurse to the same function, you're using up more stack.
Right.
You call the same function that you're in, arguments are going to be pushed, your stack comes down. So obviously, if you just keep recursing and recursing and recursing, at some point, stacks aren't infinite.
That's
you
true.
Blow out stack, you shut down. To mitigate that issue in languages like Lisp that focus on recursion as being the fundamental way to iterate rather than for loops or while loops or do loops, they looked at the problem and said, well, we can do this thing called tail call optimization. So we'll see that sometimes, TCO, or tail call elimination. And what happens is in the assembly code, if the very last thing this procedure or function does is call itself, then instead of pushing new variables on the stack, it literally just resets the stack pointer to reuse the position it already has, because it doesn't, there's nothing else the function is going to do, so it doesn't need any more entries on the stack. And you're going to be replacing the previous values anyway. And you end up calling yourself without using stack.
Right. I understand.
In order to do that, the call to yourself has to be the last thing that's done. And some languages provide it and some languages don't.
Okay.
So I'm wondering if F# guarantees that or not.
Well, let's explore that for a minute. It sounds to me like with tail recursion, the one thing you would have to make it work is that you wouldn't have to pass any new variables. Like if you had a recursive function that took an input, and you were passing that parameter down each recursion, then would you be able to do tail recursion that way by simply moving the stack pointer? What if you were passing a different input down?
No, but you can, and that's the reason why it has to be the last thing you do. Because when you make a call and you pass arguments, it puts room on the stack for those arguments, right?
Mm-hmm.
For the tail call optimization to work, it can't use any more stack, so it just repositions so that the new arguments replace the old arguments. And that's only safe if the function knows you will never use the old arguments again.
Right.
Which it can only guarantee if that call is the very last thing that happens in the function.
Okay.
Because there's no more code to use those original input arguments, so it's safe to overwrite them. Does that make sense?
Yeah. Yeah, absolutely.
There's no longer any use of them in the function. So one of the things you'll see sometimes when people fail to make a proper tail call is you'll often see like read input, and then there'll be an arithmetic operation that follows it, like +1 or something.
Yeah.
And that doesn't work because the call's made and then it returns to the original function and then does some math, which then uses the original input arguments, which have now been overwritten. The compiler or the interpreter knows that and goes, well, I can't tail call optimize this. So it does the recursion, but it burns through stack.
In my experience because I love recursion. That is absolutely one of my favorite things about programming. Yes, I love recursion.
Wow.
Based on what I think you're telling me about tail recursion, most recursive functions, if they're written the right way, should operate that way. They should be valid for tail recursion.
However, the language implementations or the language specification may or may not guarantee that it'll optimize it, even if you code it like you did here, where it is in fact the last call. So it depends on the language.
You know, this discussion about blowing out the stack makes me want to do a simple test. I don't know how long we would have to do it, but if I just ran this and just pressed enter the whole way down, how long would it be before it ran out of stack?
Well, did you see the previous video I did of comparing APL to BQN?
No, I haven't watched that one yet.
We haven't watched our own videos, man. We got 8 our own dogfish.
That's true.
Well, you weren't there, in fairness. I was solo on that flight.
Yeah.
But one of the things that Marshall added to BQN was a control structure, a specific while that he guaranteed had tail call optimization. He said, because if you use these other ways of doing a while loop, it won't optimize. No matter how you write it, it will eventually chew up your stack. So I used the one that he said was safe, and then I ran it and I just let it run. It was going and going and going and going, and I was watching the memory monitor and it never went up. So,
well, that might be an experiment to run in this too, to see if it is.
We can test it on the get countdown instead of read line. put in something bogus, like, you know, XXX or something, just anything that's not a valid integer, and run it. And it should just go into a hard loop.
You want to try it like that?
Do it. This is what I did in
Okay.
BQN.
All right.
And then we'll look at your system monitor and see if it's the memory's
Let's
going.
try it from
The faster one.
yeah.
Command XC.
So, okay, so here, well, I haven't compiled it, so we'll just do it from the run command.
Yeah, just run. No, you can't give it an argument.
Well, it doesn't even matter. Oh, yeah, that's right. I can't give it an argument, can I?
Yeah,
All right.
you give it no argument and it'll just sit there and
Yeah.
ask for countdown indefinitely.
Sure.
So just run. Come on. Okay.
Well, how would I monitor the let's
Just
see
bring
if,
up your system monitor on Windows and see if you're running out of RAM. Or just watch the one process and see if its RAM consumption's going up.
yeah, I'm looking at it right. Let's see. That's I gotta figure out which one that is. You keep bringing up these things I didn't prepare for. It's it's taken a while. Let's
It's going now.
see.
It's not stopping.
Man.exe.
I'm assuming they wouldn't give it a stack size that's all of the available memory in the machine, that they would have some, you know, maximum boundary on the stack size per process.
And on the other hand, it might be doing the tail call optimization.
Well, you coded the function properly. Let's talk about pure functions.
Okay.
Do we have any pure functions?
Hold on, I'm going to go back to this was where this
Which
started.
ones are they?
Let's see. Well, get countdown. No, get countdown is not pure because it calls another function. There's only one here that I see that's pure, and that's this one. Is it good?
Is it good?
Mm-hmm.
So takes its input I, compares it not equal to 0, returns a new value wrapping around I or none.
Yeah.
Yeah, that looks pure to me.
That's pure.
What about the next one?
Well, this one's not pure because it modifies the output environment. And this is where we kind of had a difference of opinion, and you were very clear that that's not pure from a functional point of view, and you were expressing why.
Because it changes the environment that it's running in. So generally, I think I/O, you just assume side effectful. I mean, that's the definition of a side effect, is modifying the environment. So what else?
Now, the rest of them, the other functions in here, like the get countdown, this is doing a try parse, but its calling is not good. So that's going to affect the environment.
Exactly.
If it only called is it good, then it would be pure. But because it's calling is not good, it's not.
Maybe. The try parse is a question mark because we don't know what that function's doing. If that function depends on something in its environment, like a global variable, or does something outside of itself, or we would usually assume something like that, but we didn't write that function, right? It's in the .NET library.
You make a good point. We don't know what's inside try parse. From what we're seeing, it's pure as long as try parse is pure.
Exactly.
I'm guessing try parse is pure because all it's doing is taking an input and trying to convert it to an integer. I can't really imagine why they would be going out, but they could be going out to some kind of a culture setting.
Well, we know that we could write a version that was pure, right? We know we could write a parse that would only act on its input, do a calculation, and produce a result without depending on anything around it, without changing anything around it. So we hope that the people who wrote that did the same.
What I'm curious about, if you don't mind my saying, when it comes to the question of functional purity, is there another category, let's say, for a function that doesn't do anything, like it's not modifying any of the declarative data? You got all this data, because I tend to think of something that pure as I passed in some data and it didn't do anything to it. It gave me something new. It didn't change anything that I put into it. But if it, for instance, reached out to a global, like a culture value, that's something that you'll run into with Microsoft. My thinking, and not having any experience in functional programming, trying to understand the difference, is that if I pass something in and it doesn't change any of it, then to my mind, that's functionally pure. It didn't change anything else. It just gave me a new value. But what you're telling me is that that is not the definition of pure and functional programming. And my question is there a term that falls into that category?
No, not that I know of. I guess we can invent one called mostly pure, sort of pure,
Like mostly
pure-ish.
harmless, right?
Pure, yeah. The test that works best is that idea of the table lookup. And the problem is, even if something doesn't modify in the environment, if it depends on something outside of itself, then it's a possibility that the next time you call that function with the same inputs, you get a different result. And that collides with the idea of I can reason about my code, right? Reasonability is saying, every time I get this input, I'm guaranteed to get that output. But if there's something I don't know about that could affect and change that output, even though I'm not doing anything, I can't reason confidently about it.
Mm-hmm.
Perfect example, time of day, right? Call time of day. Well, it depends on the time of day.
Right.
So what else in here? Anything else that's pure or could be pure? Let's see, read input. What do you think?
Well, read input outputs to the, I mean, from the definition that we're talking about, the pure definition, the only one in here is it good? That's the only one that takes one input, returns one output, and it doesn't affect anything else in the environment.
I think what's interesting is how hard it is to maintain purity when you have a function, call a function, call a function, and you're like, well, they all look pretty pure, except this last one I didn't look at is doing something. And this is where I think the language would help us if it could, like the type inference, it could say, it can have a declaration where you try to say this is a pure function, and it would tell you it can't be because of this violation or that violation. But it doesn't look like F# is making that distinction. It's up to the programmer through discipline to write purity and check for purity themselves, right?
I agree, but you know me, when it comes to that kind of thing, I'm a big believer in programmer discipline. My question is, what is the greatest value of a pure function?
The more of your code in pure functions, the more you can reason about the code you have. I mean, it's just the unpredictability of mutability that causes us to struggle. And when we're reading our code, we're human compilers, we're human executors. We're reading the code as if we're the CPU and we're the interpreter, and we're building up state in our head and seeing what's going on. And the more mutability you have, it's the more context that is potentially confusing, right? In fact, a lot of times we have to rely on a debugger just to even figure out what's going on because we've got so much mutable state. But if I look at a function and most of my stuff is pure, then I can very easily go, well, nothing mysterious is going to happen here. It all depends on the input.
Mm-hmm.
As long as I'm giving it the right input, I get the right output. That's my take on it. You're talking about doing more functional programming.
Mm-hmm.
There are other functional languages in this family. So my understanding is F# is in what's called the ML family.
Mm-hmm.
It's somewhere down the line in its ancestry is a language called ML, which strangely enough stands for meta language.
Yep.
But it goes back to the 60s or 70s. My understanding, the modern usage of that is called SML, standard ML, and there are some implementations out there. But since then, its offspring have been Haskell, OCaml, probably the biggest ML family of languages. And it's actually quite a popular modern language, OCaml. In fact, OCaml was a strong influence to Rust. And then F# was influenced. And the way that I think we know that is the similar syntax.
One thing to know about this language is everything that you use has to be defined before it. And that's even true if you're compiling it into an executable. It'll come up and tell you, like if I put this if I put this above get countdown, it'll tell me it doesn't know where get countdown is.
That is interesting. There are
Mhm.
not too many modern languages that have that restriction. In theory, this supports a one-pass interpretation or
Right.
compiler
That's what I was
because
thinking
everything
exactly.
it needs to use has already been defined by the time it encounters it.
Mhm. Other than that, there's just this reuse of this match thing, which is the preferred way of working with options. At least to hear Scott Washington describe it, and I from everything I've seen of him doing, I would really consider him to be a preeminent expert about the language. He has worked with it absolutely thoroughly and documented it thoroughly. So I tend to follow what he's saying. He's kind of the master when it comes to this. And he's pretty clear at saying using these special tools for options like is none or is some, that's not the way you want to do it because that's not the functional way. That's not the way that is making that is because the doing it that way is making the programmer be more imperative in his testing for valid values. And yet you could make the same argument here. Doing a match, you're still going to have to do an imperative here to say, is it equal to none? Then do this. So maybe
Um,
not as imperative, I guess.
what do you think about using these match expressions? Do you like it?
Yes, I do like it. And the reason is falling back to an old prejudice, which is, again, I prefer the declarative. I think the declarative is definitely more readable. Sure, I could change this to say, X is equal to, or say, if try parse this value with a let ahead of time. I mean, I can do it all imperatively, but this is really simply saying, take the input, try to parse it. If it parsed successfully, then call is it good with the value that it parsed into. I like it because it's declarative. It's easier to read. Simple enough. It's easier to read for me.
Yeah, I agree. So let's pull up the pin on Erlang because this leads right into that. In Erlang, variables are only immutable. You cannot create an immutable variable. So the functions don't have to be pure. In fact, there is no notion of function purity in Erlang. Functions can be side effectful. You can call IO and do things like that. But you can't reassign a value to a name once it's a value. As soon as you assign a name a value, it has that value. It's interesting how you have to code it in a recursive fashion when you want to do an iterative transformation where values change. It's interesting. But the other thing that you may like, if you like this match, is it uses pattern matching everywhere. So this sort of thing you've done here, this is the way you code most code in Erlang. It's going to be a lot of pattern matching because, to your point, you cannot have mutable intermediate variables. So it would be interesting to see you do this in Erlang. What
Yeah.
makes Erlang the oddball that it is, syntax is a little different. It's not quite ML. It's actually based on Prolog. I find it pretty easy to read. It's a little weird with the periods and the commas and the semicolons being significant kind of boundaries of the syntax. But the real thing that makes Erlang what it is the way it runs. That you're running on top of the OTP, the beam, writing code in these small processes that are encapsulated, that talk to each other via messages. You're very aware, unlike most code, like if we look at this code, we see the logic of the program,
Mm-hmm.
but we don't really have any idea at the process level what's happening. Does a process get instantiated? Does it start up? Does it shut down? Is there concurrency going on? Like there's IO, is it asynchronous? Like I don't think it is, but I'm not really sure. The minute you start writing code in Erlang from the very beginning, you're like, I created a process. It's spawned. It responds to messages. It sends messages to other processes. It has a potential lifetime. It can shut down. I can attach supervisors to it that are automatically like you're immediately thinking about the concurrency of its execution.
Mm-hmm.
It's in your face. So that's what I feel is most different about Erlang. And if something you care about, which is process boundaries, concurrency, recoverability, then it's a huge boon.
Mm-hmm.
If it's something you don't want to have to think about, it could be annoying. So we'll see about Bye Bye Hello World.
The only other thing about the code here that I tried to demonstrate is that it's all about the functions. It's one thing that it's nice, a simple example like this. It really is all declarative. There is no imperative statement until you get down to the bottom. That's what you're seeing here, is that we've got these two functions, which is very different from when we first started BBHW. Our first evaluation of BBHW was purely imperative. There were no there was no functions in it. It was just purely declarative all the way through it. Everything's mutable. And now we're getting further and further down, especially when we get into functional, and you see it's all declarative. We've got these are the things that happen, or these, and we're going to call. Here's get countdown is going to be called twice, and read input's going to be called twice, once from here and once from itself. But it's all, I really, really like coding this way. At least
that's great.
My first example into it, yeah, I do like it a lot. But as I said before, I really like a declarative model. So
you like this, but it's going to take more harassment for me to get you into array programming.
Well, it's funny that you say that. I was thinking a little bit about that after the last discussion that we had. I think my objection to the array programming really just comes from, oh my God, I remember how challenging APL was with all of its symbols, and do I really want to go back into that? But then, after that, I thought to myself, it's only going to be hard until you get your head into it again. Then you'll figure it out. So I'm open to it. In fact, since you're already coding in that environment for the application that we were talking about before, then I'm going to be very interested in looking at it. Yeah. Yeah, if it's really going to
BQ in and do it.
Well, it's like anything else, I'm always interested in the best solution. What's the best tool for the job? Like, I enjoyed working in F#, but as it stands right now today, I have no application for it. I would like it if I did. It'd be great. But the environment that I'm working in, nobody else is doing it. Nobody else has any knowledge of it. So I would have to move into something else. If I had the opportunity to do something in the .NET environment, like if I took up a new contract and they said, we want you to build this and we don't give a damn what you write it in, yeah, I might choose F#. That might be really fun to do something like that. By the way, for those of you interested in F#, we're going to include some links to Scott Blashen's website and some of his videos. And hopefully the people that are doing F# or interested in F#, you're really going to benefit from that. So
yeah,
that's all. That's all
cool.
I have for today. So next you're going to be looking at doing J#, or not J#. Jeez, where'd I get that? Doing something in J.
That's what Microsoft originally called their Java clone.
Mm-hmm. I think so. Yeah.
But J is the language that's been around before that.
Mm-hmm.
And it was Ken Iverson's next language after APL. So it's another one of his creations.
Yeah. That'll be exciting.
Next week, I have a week to do J. And
all right.
We'll probably, hopefully a week or two after that, we'll get an interview with Bob Terrio. That'll be great.
And next you see me doing it, we'll be doing Erlang. And for that, we'll see you all next time.
And when you're doing your own programming, I wish you the best of luck.